Alright, and here's going to be how to do question number 2. So what I did was I put the NH4NO3 information on the left side, and then on the right side I put all of the H2O information from the word problem. And I wrote out the equation, and the delta H was plus 25.7 kilojoules. Alright, now let's get started. So the first thing that I'm going to do is for the equation, I'll write it up here. Q is equal to mc delta T. We need to have the mass, and we're finding out it of water. So let's find the mass of water. I'm going to use the milliliters that it gives and then the density. So I'm going to go 195 milliliters, do my H, and put 1 milliliter at the bottom and 1.25 grams at the top from the density right here. And then once I did that, let me do 195 times 1.25. Perfect. I got 243.75 grams. Sorry. Perfect. So I'm going to write that down here. 243.75 grams. Alright. And I'm gonna... Okay, so we have the mass, which is M. C is the specific heat. We have that. Change in temperature, we're trying to find... I can write it down here. T final question mark. So that's what we have to find. But we also need the Q. So let's get that Q value first. Let's get that Q. Alright, so what I'm going to do is I'm going to do a mole-to-mole ratio. But in order to get a mole-to-mole ratio, I need a equation that has water in it. So what I did was I actually rewrote this equation, broke this NH4NO3 aqueous into an equation that has water in it. So what I did was I went NH4NO3 soluble goes to N2O aqueous plus 2H2O. And I'm assuming that the delta H for both of them is the same. So just making sure that I have everything set up right. I'm going to check. I have 4 H's on this side, 4 H's, 2 N's and 2 N's, and 3 O's, 1 plus 2 O's, so 3. Perfect. Everything is right. So I'm going to be using this equation because it has water in it, so then I can do a mole-to-mole ratio. Alright, and what I'm going to do is I'm going to go 75.0 grams right here of NH4NO3 and the molar mass is 80.043 grams NH4NO3. Sorry, I had to squeeze it in there. And then that's equal to 1 mole NH4NO3. Alrighty. And then since the equation has 1 mole NH4NO3, it actually has 2 H2O, So 2 mole H2O. Perfect. And let's make sure the grams and moles cancel. So grams of NH4NO3, okay. Moles, and then we're left with moles of H2O. Perfect. Okay, and then when I solved this, I got 1.87 moles of H2O. And why I'm doing this is I'm going to show you the equation right now. Okay, so for Q, the equation is delta H is equal to Q of the reaction over mole. Perfect. So we have the delta H, which is 25.7 kilojoules. But I want to turn that into joules first. So 25.7 times 1,000 to make it into joules. So 25.7 times 1,000 is equal to 25,700. Okay, so I'm going to go 25,700 joules is equal to X, because we're trying to find out the Q value, over that 1.87 moles that we just found. And when I multiply the 25,700 by that 1.87 moles, I get that X is equal to 48,059 joules. Perfect. Alright, so now we're ready to write out the equation. And I used X, but you could also use Q since it's the Q value. So I'll just put a Q right there. Okay. Then I will write out 48,059 joules is equal to the mass, which we found earlier. You can highlight it. Perfect, right there. 243.75 grams times the specific heat, which is right here. Perfect. So we're going to get 4.184 joules over grams times degrees Celsius. Perfect. And then that temperature, which is TF minus the temperature that was given, which is the initial temperature, 22.3 degrees Celsius. Alright. So now we have all of our information down, and we're just trying to find that T final value. Alright, so what I did first is I'm going to multiply these two, and what happens is since both of these have grams in it, grams will cancel. And when I multiply those two together, I got 1,019.85 joules over degrees Celsius. And then I'll carry down that TF minus 22.3 degrees Celsius, as well as that 48,059 joules. Then I will divide this to get the temperature by itself. Perfect. And then 1,019.85 joules over degrees Celsius. And see how there's joules on the top and joules on the bottom? It'll cancel. And when I did this one, I got a long number of 47.12359,661. And this value, I'm going to write it all out. So this is the value after you go t final, whatever that value is, minus that 22.3. So what that means is the t final value, to find that, you have to go 22.3 degrees Celsius plus the 22.3 value. So you get 47.12359,661 plus 22.3, and you get 69.42359661. But we'll only really need just 3 decimal places. Sorry, 3 sig figs, because that's what it was at. So the final temperature is equal to that. And you can check your answer by going like this. So I went 243.75 times 4.184 times that difference between, so when you go 69.4 minus the 22.3, you get that long number right here, 47.1. I'll just type that in so we get the exact number. 47.12359,661 equal, perfect, and you have it right here. 48,059 and 48,059. So we know that we got the correct TF value for the joules that we have, and that is what I got for question number 2. Thanks for listening.